Welcome to Chapter 9, Day 13, Section 9.6, Writing Equations from Geometrical Definitions. So at this point you have now learned every conic shape that we're teaching. So we know parabolas, circle, ellipse, hyperbolas, and this diagram on the first page right here really demonstrates all those parts that we know. So recognizing these from their equations, we've talked about this frequently, but again, it's good to have it in one spot. So a circle, the x squared and y squared term have the equal coefficients. Ellipses, the x squared and y squared terms have unequal coefficients, but the same sign, both positive. Hyperbola, x squared and y terms have opposite signs. Again, that's huge. The negative sign tells you what way it opens. And then our parabola only has one squared term. Now keep in mind, this is all true if there is no xy term. And again, we have that worksheet visual for you to look at about if there is an xy term with the discriminant and all of that work there. So let's jump in. We have a couple examples here. So we're going to find a polynomial equation with integer coefficients for the set of coplanar points described. Then let's identify the conic section based on what's above. We can kind of decide what shape it is. So first thing, it says for each point, its distance from the fixed point, -3, 0, is twice its distance from the fixed point, 3, 0. So I think what's helpful is let's call this point xy, and distance is all about distance formula. So if I show this side is the distance from each point, so point xy, from -3, 0. Well, that would look like x minus -3 or plus 3, and it would look like y minus 0 squared. So I just took this first portion and put it into the distance formula. I'm going to erase that just because that's very close to my problem and I want to get confused. Then it says it's twice its distance from this point. So it's saying twice the distance of the point xy to now the point 3, 0. So x minus 3 squared, going to be y minus 0 squared. Okay, so half the battle is just writing that equation, showing that each point, its distance from the fixed point, -3, 0, is twice the distance from the fixed point, 3, 0. Now the rest of it is just algebra. So the first thing I'm going to do is get rid of these get rid of the square roots by squaring it. So left side just becomes x plus 3 squared plus y squared. I have to square the right side, so this becomes a 4. And then in parentheses, I have my x minus 3 squared plus my y squared. Okay, now I'm just going to do some FOILing. So this becomes x squared. This would be plus 6x plus 9 plus y squared. Before, still on the outside, I'll wait to distribute that till the end. You get x squared minus 6x plus 9 plus y squared. Well, nothing changes over here. I'm going to now distribute. Notice none of these are like terms. You're going to just have to wait it out. So you get 4x squared minus 24x plus 36 plus 4y squared. Now, I need to have it equal 0, or actually I'm going to just see what it kind of does. Well, if I put everything to one side, I'm going to get 0 equals 3x squared minus 30x plus 27 plus 3y squared. Hopefully something's jumping out at you that you can take a 3 out of each term, a nice GCF. So in the end, I'm left with x squared. I'm going to do some rearranging. Plus y squared minus 10x plus 9. So in the end, this is kind of the equation I'm getting after I simplify all that algebra. While looking at this, you should be able to tell what kind of shape it is. Looking at our information above, I'm noticing that the x squared and y squared term are equal. Well, that to me then is a circle. So this is a circle. Okay, and again, that's because the x and y term have equal coefficients. Hopefully that's not too bad. I think the hardest part is just writing that equation. The algebra is pretty self-explanatory. So let's do the next one. It's saying for each point, and again I'm going to call it x, y, its distance from the line, x equals 3, is twice as far as its distance from the line, y equals negative 2. So now I'm not given a point, so I'm not given an x, y point. I'm given that the x is going to be 3. Well, if I kind of think about that, maybe I'll think about it over here. If x is 3, it's this line right here. Notice y could be anything. It could be positive, it could be negative. We don't know, and we actually don't care. We just know that it's the line x equals 3. So when I write this equation, let's be aware, again, it's distance formula. Again, it would be x minus the line 3 plus, it could be any y. So this is the y from the point minus any y on that line. That is how we're going to write the distance formula, because it's any y that we have. So in a way, these actually cancel out. Okay, that should make sense. Well then, it also is twice its distance from the line, y equals negative 2. So this time, this line right here, it can have any x it wants. We don't care. When I do my problem, it's x minus any x possible. Still a distance formula, y minus negative 2 or plus 2 squared. So again, it kind of washes out, it goes away. Okay, so whenever you see comparing to a line, make sure you think through what all the potential values are. So here I go, this is what I'm left with. Kind of simplifies very nicely. And just like the last problem, I'm going to square both sides, get rid of that square root. So my left side is just x minus 3 squared. My right side is 4 times y plus 2 squared. So foiling out, x squared minus 6x plus 9. This time I'm just going to distribute as I FOIL. So you should get 4y squared plus 16y plus 16. Again, get everything to one side. So I'm going to get 4y squared. I'm going to again put my squared terms first, just because that's how we're used to seeing it. Plus 7. So this is my equation now, and I instantly start looking at what shape can I be. Well, I notice I have an x squared and a y squared, so parabola is out of the case. Notice the numbers are different, the coefficients are different, so can't be a circle. Notice the coefficients are different and one is positive, one's negative. So right away that should jump out, hyperbola. just a couple more, and then I'll set you free. Actually, just one more. So this one, for each point, again, keeping with what we're doing, we're going to call it xy. The distance from the point -3, 1 is half its distance from the line y equals 4. Take a moment, pause this video, and see if you can write that equation. Okay, hopefully you paused the video and tried it out. This is what your equation should look like. You actually have two options. It could look like this. Equals half of the distance. Remember, it's a line, so the x's kind of go away. So you could have written it like that, or you could have done double this side. Like so. So either one would have worked. I'm actually going to keep with the last one just because it's the last one I wrote, but same idea. Luckily these cancel out because it's the line. I'm going to square both sides. Hopefully you're catching on that pattern happens every time. So you get now 4. This is x plus 3 squared. And over here, all I have left is a y minus 4 squared. So now we're going to do just some basic algebra with it. We're going to FOIL, combine like terms. So when I FOIL, I'll get x squared plus 6x plus 9 plus y squared minus 2y plus 1. The right side FOILs nicely. Make sure we distribute the 4. And now we're going to get everything to one side. So I'm going to have it go like this, 4x squared. If I subtract over, I get plus 3y squared. And again, I'm putting my squared terms first just so I can see them together. Okay. So here's my equation now of everything on one side. I look at my x squared term and y squared term. Notice that they're different, so I'm not a circle. Notice I have 2 squared terms, so I'm not a parabola. They are the same sign, but they're different coefficients. So that means ellipse. Okay, so everything really builds on those geometrical definitions that are laid out on the first page. Pretty much once you get the equation, you're good to go. Please take your time with these. If you're getting stuck, please ask questions. I think the hardest part is just writing that equation, but please use these definitions right here to help you. They're very, very helpful when there's no xy term. Okay, good luck.